question which I am facing right now, just at this particular junction, the question which stands in front of me, okay, I got a proof that light is a wave. Young's double-slit experiment, good enough proof for me. I have another experiment called photoelectric effect. The very first topic which we studied in modern physics proves, literally screams out that light is a matter. So which version should I stick with? Light is a wave, light is a matter. It's very dicey. So here comes along a guy called D. Broglie. So D. Broglie came up with his version of what exactly the light is and how, by resolving this particular question, whether light is a wave or light is a matter, he came up with an alternate theory about everything around this world, or so as to speak, the whole universe. So what does he have to say about the whole universe and the light? Let's find out. Now we'll study about D. Broglie's version of light. Exactly. What happened, as I've discussed in earlier parts as well, that there was a conflict between sect of people vouching for the idea that light is a matter, the other sect of people vouching for the idea that light is a wave. So the clash between these two sects was kind of very fearsome, given the fact both of these ideas, one light being as a wave and light being as a matter, had solid proofs, irrevocable proofs, or let's say experiments which kind of consolidated the idea that light is a wave. The other experiment consolidated the idea that the light is a matter. One being photoelectric effect, which consolidated the idea that light is definitely a matter. On the other hand, I have Young's double-slit experiment, which surely consolidated the idea that light is a wave. So I have two completely contrasting ideas, or let's say the proof of their existence. Now, which one should I pick up? So comes D. Broglie. So D. Broglie actually comes in and gives his idea what should be the light, given the scenario about that particular question. So he came up with his version. That is, what he witnessed is the wave theory of electromagnetic radiation. That is, the sect of people, pushing the idea that light is a wave. It explained the phenomena of interference, diffraction, and polarization. These phenomena couldn't have been explained by considering light as a matter, which in turn was beautifully explained when you consider light as a wave. So that's why you are more inclined, when you're studying these phenomena, that light is a wave. On the other hand, the quantum theory, which we come to know, explain Compton effect, BBR, black body radiation, X-rays, photoelectric effect, and whatnot. So now they are giving good amount of proof and experiments and data to suggest that light is a matter. So D. Broglie came up with a fascinating idea that radiations, or let's say the light, they have dual nature. That is, they are both wave and particle nature. Now the funny part over here is, for wave theory, interference, diffraction, and polarization, I stick with the wave version. That is, light is behaving as a wave. When I'm studying something else, I change my perspective that light is a matter. And on the other hand, I'm saying light is both matter and wave. So it's all getting jumbled up. That is, one guy is saying it's wave, the other guy is saying it's matter, and then comes along a third guy and he says it's both wave and matter. So he gave this idea with a twist. That is, they don't exist wave and matter simultaneously. That is, I don't exist as a wave and a matter simultaneously. I exist as wave when there is a phenomena associated with wave. That is, if you are giving me a disturbance corresponding to that of a wave, I'll behave like a wave. If you are giving me a disturbance corresponding to a matter, I'll behave like a matter. I will give you signals that I'm a matter. So that's what he said. Because both the proofs were irrevocable. You cannot, just dodge that bullet. So that's what he exactly said. So Louis de Broglie suggested that the particles like electrons, protons, neutrons, etc., they have dual nature. Okay, that is, they can also have particle as well as wave nature. So he took this idea, that is, he answered a particular question that light is both matter and a wave, and he took this idea to a whole new level. That is, he took out the flip side. That is, previously you had a notion that light was a wave. You're cheering up for a wave. Then comes along photoelectric effect, and then there was a clash between wave matter. Then he suggested that it is both, so wave and a matter. So if you thinking that a particular entity is a wave and it turns out it's both wave and matter, can't I actually think it in another way that if I'm thinking a particular substance to be matter, it can be both matter and a wave? So that's what he considered. And why did he pick this idea? He picked this idea simply out of the hunch, let's say. It's a gut feeling. That is, the nature loves symmetry. He said that the God, or let's say whatever be the entity who has created this nature, cannot be biased, right? That is, few things will be both matter and wave, few things won't be matter and wave. Few things will be simply matter, few things will be simply wave, and few things will be wave and matter. So he said this doesn't happen, right? Nature loves symmetry, so everyone is both matter and a wave. And the reason is, universe is made up of particles and radiation. So I have radiations coming in, I see the celestial bodies and myself as a matter. So if these two are made up, or these are the only two, let's say, entities existing in the universe, they must be symmetric. That is, the particles which I perceive as a particle, they are both particle and wave. Radiation which I perceive as a radiation, they are both wave and particle. So that's the reason behind it. Now, this is a point which I stressed on the previous slide. That is, in no experiment, matter exists both as a particle and as a wave simultaneously. You cannot have an experiment. We still haven't got an experiment where we have got an evidence suggesting that it's matter and a wave simultaneously, right? So it all depends upon the disturbance you want to give. If your disturbance is more inclined of getting a wave response, I will behave as a wave. If I am more, or your stimuli is more inclined to get a matter response, I'll behave as a matter, but not simultaneously. So please keep that in mind. Broglie actually stressed this idea after he suggested that his idea of matter existing as both matter and waves, waves existing as both matter and waves, based on these notions. Now, he came up with the fact that there is something called de Broglie wave or matter wave. And what exactly is de Broglie wave? So he said that each matter is associated with a wave. That is, if a particle is moving, then it's associated with a wave. That is, it's carrying a wave of its own. So according to de Broglie, a moving material particle can be associated with a wave. That is, a wave can guide the motion of the particle. That's one and the same thing. Either express the particle as a wave or express wave as a particle, vice versa. The waves associated with the moving material particles are known as de Broglie waves or matter waves. So please keep in mind, that is, we are looking at different objects, right? I'm moving my hand in front of the camera right now. I'm shaking my head. So objects are moving. The earth is rotating, but we never can imagine or visualize that it's associated with a wave. But according to de Broglie, it's associated with wave. There is a wave which is totally originated and for earth. There is a wave corresponding to my movement right now, movement of my hand, my fingers, whatever, twitching of my eyes. So matter waves, anything which moves has a wave associated with it, and it's called matter waves. Moving on. Now, simply put, what we'll do right now is put the mathematical expression to de Broglie's idea. So, according to quantum theory, the energy of a photon is given by E(h(c) by lambda. So, this is the energy of a photon. And energy it carries, according to Einstein, was E is equal to mc square. So simply equating these two, I end up getting that for a photon, the wavelength associated can be said to be lambda is equal to h by p, h being Planck's constant, p is the momentum of that particular photon. So I got the wavelength associated with a particular photon. Now please focus on the expression which we got. Lambda is equal to h by p. Lambda is a property associated with wave. P is a property, or momentum is a property associated with matter. So I have right now related wave and matter simultaneously, right? That is, the wavelength of a photon is somehow related to the momentum of the photon. That is, the wave-like nature is related to somehow its matter-like nature. I can regress this idea, or let's extend this idea to any substance in the world. So this is what we will do. If instead of a photon we have a material particle of mass m moving with velocity v, then the equation simply comes out to be lambda is equal to h by mv, because in place of p is now mv, which is expression for the de Broglie wavelength or matter wavelength. Now the different conclusions which I can make out about de Broglie's idea are: de Broglie wavelength is inversely proportional to the velocity of the particle. So if the particle is moving faster, then the wavelength will be smaller, and vice versa. So if my momentum is quite high, my wavelength will be small, right? If my momentum is very low, my wavelength will be very high, correspondingly. If the particle is at rest, then the de Broglie wavelength is infinite. So you cannot imagine an infinite wavelength wave. I cannot do that, right? Because there is no periodicity, there is no to and fro motion of any substance or any energy. So this is unimaginable. Third, de Broglie wavelength is inversely proportional to the mass of the particle. As we know that wavelength is inversely proportional to its momentum. Momentum directly related to the mass, directly proportional to mass. Hence, the wavelength is related inversely to mass. Matter waves, like electromagnetic waves, can travel in vacuum, and hence they are not mechanical waves. So if you are considering these type of waves to be the waves which we witness while producing in strings, that's not those kind of waves. It's purely the types of waves which we associate with radiation. It's exactly like it, just that its wavelength is corresponding to its momentum, and momentum depends upon your mass and velocity. So I have ample choices, and hence ample amount of wavelengths are available. Matter waves are not electromagnetic waves because they are produced by accelerated charges. Now I said that in the previous let's say point, we discussed that they are exactly the same, but the fact is I am exactly similar to my brother doesn't mean that we are one and the same. Means that few of my traits, or let's say many of my traits, are identical with that of my brother. So similarly it goes with matter waves and electromagnetic waves. Many of the characteristics of matter waves can be identically mapped to that of electromagnetic waves, but they differ in one single point, and that's a very important point: the mode of creation. Now for the creation of electromagnetic waves, you need to put electric charges in motion, or let's say, not in, to be precise, in an accelerated motion. Its velocity should change. If the velocity of the charged particle is changing, it will result in the production of electromagnetic waves. Whereas for matter waves, when the object is moving, it's sufficient to produce matter waves. That's it. Rest, all the characteristics are almost same or almost similar. So that's the basic difference between matter waves and electromagnetic waves. That is, they don't, or their source of origin or their way of coming into existence, they are completely different. Now, matter waves are probability waves, amplitude of which gives the probability of existence of the particle at that particular point. Now, I can clearly visualize what is electromagnetic waves. Okay, so light is moving, the energy is transmitted from one point to the other point. So I can visualize what light wave, let's say what a radiation is or electromagnetic wave is, but it's hard to fathom the idea of what matter wave is. What exactly is oscillating? What exactly is moving? How are they created? So, as I said, the mode of creation is when the objects are in motion. Now, the waves which are created are actually, in a mathematical sense, the variation of their probability at different points. What I'm trying to say is, if I ask you to plot the probability of you being at different instance, at different point of time, you will end up describing it with the help of a function. Most probably at a better position, let's say fxt. X is at what position you were, and t is the time. So you will end up getting a particular function. Now, in case of matter waves, what we get is, according to its momentum, its probability in some regions is very high, then it's very low, and it's almost zero. Then it's very high, then it's very low. Then again it's very high and it's very low. And what is the wavelength of it? That is, when the wavelength, or let's say the probability of finding it is minimum, then it's maximum, then it's minimum. So that's half of the wavelength. Who decides this wavelength? That it's dependent upon the environment, right? So if I am moving, I have a wavelength, and wavelength is basically corresponding to the idea that it exists, in the probability of its existence at a particular moment. Increases, decreases, increases, decreases. So the wavelength is corresponding to that increase and decrease in its probability of existence. That is, let's say I plot a graph x, and this is probability, let's say percentage of its existence. It's 0 at x equals to 0, then it moves up, then it goes down, then it moves up, then it goes down, then it moves up and it goes down. So I can say that this is the wavelength, obviously half of it. This is a wavelength, percentage of existence. So there are some places when an object is moving, it's highly probable that you will end up finding the object over there. So the matter waves is basically plotting of the probability with respect to distance. Okay. So please keep in mind that's the matter wave which we are talking about.
So let's have a look at the hydrogen atom from de Broglie point of view. De Broglie actually suggested that matter can actually act as a wave when they are associated with their motion. So whenever matter has a motion, then I can attribute it to have a wave like nature. So right now I have different views, that is, this is a radial view, this is 3D view. So according to de Broglie, so if an electron is moving about the atom, so radial view is actually better. So if if electron is moving about the nucleus in an atom, then it's radiating wave. So the wave kind of looks like this. That is corresponding to its motion, how it's moving around the nucleus. This wave is denoted by this purple ring, because electron is denoted both as matter and wave. So whenever you want to denote a particular entity as both matter and wave, and it's moving, you can denote it using these rings. Matter is denoted by a dot, whereas a matter and wave, both of them, when you're denoting them simultaneously, you kind of denote it through a ring, which is, or through the locus of their path. That is, they are moving about a particular path. So the whole path is also covered. That is, they exist everywhere, and they are radiating waves, so it's kind of oscillating in nature. So this is the way through which you can picturize or visualize what de Broglie actually end up saying. So if I want to picturize proton moving, or imagine how a moving proton will look like, let's say it's moving in a straight line, so it will be denoted by a straight line. A proton will be denoted by a solid straight line. So this is a solid straight line moving or with vibrating like this. The same manner in which this is vibrating. So this is how you can perceive whatever de Broglie end up saying.
De Broglie wave. Now, what we are doing right now is we have discussed about de Broglie, and now we'll try to work out a particular problem based on this particular idea. Now, So let's start off with the first question. A particle of mass m is confined to a narrow tube of length L. Find first the wavelengths of de Broglie wave which will resonate in the tube. Second, corresponding particle momenta. Third, the corresponding energy. So right here I have a particle which is confined at a distance of L, or in a tube of distance L. Now my particle is moving, or let's say particle is of mass m, it's moving with velocity v. So I know the wavelength associated with this is h by mv. So, or h by p. Now the matter waves, obviously the particle is very hard to be found in this particular position. So my matter wave will somehow be like this. That is, the probability of finding that particle at the ends of the tube is very less. And obviously I can have other probability as well, that is like this. Right. So in general I can figure out it's in multiple. So this is lambda by 2, this is lambda, then the next one which will come in will be 3 lambda by 2. So it's in multiple of lambda by 2. So I can easily figure out that is the first wave which is possible is, that is lambda by 2 is equal to L, implies h by 2 mv. So I can easily find out, so the wavelengths of de Broglie wave which will resonate in the tube basically when lambda equals to 2L. That's the first case. Then the other case will come out when lambda is equal to L. Then the other case will come out when lambda, or let's say 3 lambda by 2 is equal to L. In this case it comes out to be 2L by 3. So these are the different possible values of wavelength which I can have. That is, I can have 2L, I can have L, I can have 2L by 3, so on and so forth. Similarly, correspondingly, I can easily find out what will be the momenta. That is, given I have the wavelength, so I simply need to divide the Planck constant by the wavelength to get its momenta. So the wavelengths are these, 2L, L, 2L by 3. So one can easily find out what will be the corresponding momenta. And once we actually know the momenta, we can easily find out p square by 2L. This is the energy which they are carrying. So right now what we did is we discussed de Broglie's idea in a practical sense. So we sort of, confined a particle in a tube and asked us to find how its existence inside a tube at different points depend. So this wavelength which we have found out, 2L, L, 2L by 3. Now when in case of 2L, if you notice, there is a high chance of existence at the midpoint of the tube. That is, when you're actually witnessing a matter wave of wavelength 2L, there is a high probability of finding the particle at the midpoint of the tube. When the matter wavelength is of L, the least probability of finding the particle is at the ends of the tube and at the midpoint. That is, at L by 4 or L by 4 or L by from each end of the tube, I will have the maximum probability of finding that particle. Similarly, you can do the same analysis for 2L by 3 as well, when the wavelength is 2L by 3. Moving on. What is the energy and the wavelength of a thermal neutron? Now you need to understand what is the meaning of thermal neutron first. After that you can answer the question of what is the energy and the wavelength of thermal neutron. So thermal neutron is basically a neutron moving in a room temperature. That is, its temperature is T. So thermal neutron, it means its velocity V is 3 kT by m. So the velocity of the neutron will come out to be, I substitute the value, let's say T naught is the temperature, mass of the neutron. So this is the velocity of the neutron. Now I know the velocity of the neutron, the wavelength associated with it will be h by p is equal to lambda, implies h by m root over 3 k t naught by m. So it comes out to be, lambda comes out to be h by root over 3k T naught m. So this is the wavelength of the particle or the thermal neutron. Now correspondingly I can find out the energy. Energy, I know that it's half mv square. So we know the velocity. Velocity is this much. Substitute the value over here, we will finally get the answer. So this is me working out de Broglie's idea in some real life situation and putting mathematical equations to it. So please make sure that you understand the concept of first in de Broglie. What did he say? Why did he say the statements of his idea? Right? He ended up saying because he wanted to know exactly what light is. So he ended up favoring both, because both of the experiments, photoelectric and Young's double slit experiment, you cannot disprove them. They are solid data. So that clearly suggested that they are acting, they are behaving both as matter and a wave. There is no point of discussion going ahead. Now he further, extended that idea into thinking that if light is behaving as both wave and matter, so matter is also kind of behaving as both wave and matter. The reason of this particular notion is nature is symmetric. So most of the theory or ideas, they are given based on a hunch, and this was one of them. Then the introduction of matter waves. What exactly are matter waves? How are they different from electromagnetic waves? So please keep in mind what exactly are matter waves, because that's the notion in which students, they simply mess it up or screw it up, the whole concept. So please do keep in mind. Now you might have figured out the duality of light, or let's say duality of matter as let's say the idea given by de Broglie. Now you might consider that there was no sort of step of innovation or let's say flash of genius by saying that the light is both wave and matter, but to extend that idea to the whole matter and the radiation thing, it's quite awesome. So that's why de Broglie is appreciated worldwide. Now a very fun fact about de Broglie is that he was actually a prince in the state of Paris. Now what happened is he used to study in a college pursuing a degree in physics, higher study in physics. So he was pursuing PhD. Now in usual PhD thesis, you used to have, let's say you have to write a thesis or your work of 5 years in a book of this size, this thick. Now he being a prince, and that to his father on a trustee board, he ended up writing a paper of just 2 pages. First page contained his name and the theory, duality of matter. And the second page is what we have just studied, h is equal to lambda by t. That's all. That was all in his PhD thesis. Now given that the fact that his father was so powerful, being a most important member of this college, they couldn't simply reject the paper given by his son. So without doing anything, they simply mailed the paper to Einstein, which in fact Einstein was very amused and was very satisfied with this idea. So he grasped upon that idea, nourished de Broglie, and the rest is history. So it's a small little trivia for you guys to enjoy. So now that we have done that, so let's figure out what do we have to do next. More coming up in the next video.